Live. Hi everyone, a warm welcome to the School of Mechanical and Aerospace Engineering talk. Today we have Dr. John Heng, who is overseeing the robotics stream, and he will take you through today's presentation. So in this presentation, we will be covering a little bit more on Dr. Heng's expertise, which is the robotics stream. So if you have any questions, feel free to drop it in for us, and we'll get back to it during the Q&A segment. Now, in 2 minutes time, as we wait for more of your fellow friends to log in, feel free to make yourself comfortable, and we will start in 2 minutes time. Thank you. All right, everyone, a warm welcome back to the School of Mechanical and Aerospace Engineering talk. We do have some students that are joining us on Zoom, but we also have people joining us live on YouTube. So you may not be able to see everyone, but rest assured to know that all your questions will be answered. So now, without further ado, let me invite Dr. John Heng to start his presentation. Dr. Heng, please.
Thank you so much, Eileen. Hello, good morning, everyone. I'm John Heng. I'm from the School of Mechanical and Aerospace Engineering. And I hope this morning will be a very productive session for you. I hope to provide you all the necessary information this morning on the many disciplines and exciting opportunities that lie before you, so that you can make the right choice to come to join our school and advance your career. Okay, so welcome to the School of Mechanical and Aerospace Engineering, and of course our tagline is that when you join our school, you have an amazing journey with us. I think many of the students who have joined us found that because we are such a big school, there are so many different opportunities and experiential learning that you get when you join with us. So this is a belief of our school. Okay, so we always stress that our students that we train in the first 2 years, they will be trained on the core fundamentals of engineering. And engineering, as I'll show you later, and many people don't realize this is just how broad and wide the engineering discipline is, especially mechanical engineering. So in the first 2 years, you do the fundamentals, first 2 years, to build up the core competency. Then from year 2, year 3 onwards, you start to be exposed to either industry relevance, you do your industrial attachment. And this curriculum from the 3rd and 4th year, many times we meet our industry advisory panel once a year to meet up with the industry captains to check with them that our curriculum is up to date and relevant. So what we are offering, you can rest assured that our curriculum is always up to date. Then in the final year, and also with several projects that you'll be asked to do as well, this is an opportunity for you to test out that the information you have learned is totally usable, solve engineering challenges and problems. so that when you graduate, you find that your information is not something that you just know, but that you can also practice and be recognized by the industry. So basically, what do engineers do? If you have ever sat down to think, because I think the work of engineers are so prevalent all around us that it is taken for granted, okay? Because things work and then you don't complain about it, you just take it and you don't realize that these are the work of engineers. So basically, as the slide shows here, engineers devise solutions to problems in a clever and creative manner. They are linked between scientific discoveries and the application of new ideas to the world. So I always ask my students, what's the difference between a scientist and an engineer? So the scientists basically discover the world that is, and engineers develop or create the world that never was. So it's engineers that take the knowledge that the scientists discover and put it into a form that is usable by mankind. So that is our contribution, our gift to the world. Okay. So the value of engineering is therefore the creation of a better world, because without engineers, with all the things that you see and touch, anything that's made by men is all done by engineering. So this is something that we just naturally take it for granted. Now, if you look in the branch of engineering, there are several engineering disciplines. The most basic ones are the mechanical, the civil, the electrical, electronics. Then later on, you have your materials engineering, you have your computer engineering, bioengineering, and so on and so forth. So mechanical engineering is one of the oldest branches in engineering. Okay, people have been inventing and building increasingly more sophisticated devices and machines in order to improve the conditions of life. Now, the tagline of the Institution of Mechanical Engineers, we engineers, mechanical engineers is nothing moves without mechanical engineering. So we are the building blocks of things that move, things that you see and touch. And later on, I have a slide to show you, to give you a quick overview of just how broad mechanical engineers are, okay, just to realize, because otherwise the general conception is what do mechanical engineers do? Look after steam plants, build manufacturing, production line, that's as far as it goes. But that is far from the truth. I'll show you just how broad mechanical engineering is. So I think in the context of Singapore economy, I think this is something stated by Teo Chee Hean in 2019. Engineering is vital. Okay, this is one of the core pillars of Singapore's economy. The Singapore's economy is reliant on engineering, and it's just a matter of fact. Okay, it's not going to go away. So the jobs will always be there. There are many things to be built and developed, and so on and so forth. Okay. I think in this slide, which is really quite old already, you find that this is one of the professional categories. Okay, that there will always be jobs that whenever there are problems and challenges, urban infrastructure, coastal line, energy recovery, environment, and so on. So it's just endless amount of opportunities and jobs that are available. So what? Again, just to summarize, that in our school, these are just examples of our students and our graduates who have finished engineering in our school, and basically they are in the business of future-proofing our society. Especially now, you have a lot of cyber scamming, cyber security issues is a big issue. We've got many systems, your vehicles, transportation, healthcare, electrical systems, the supply that many of our engineers work on. Okay, so this is something that is just so broad, okay, that I don't have the time to share with you. Now, this is something I apologize for the quality of this slide, because I just put it in this morning because I went to the course site, our MAE website, just to share with you and at least open your eyes as to the areas that mechanical engineering is involved in. Okay, so this is the core research area. So these are the core research areas. So these are all areas that deal with mechanical engineering. We have micro and nano fabrication. Manufacturing is obviously a very core bit. All the items and products that we use being manufactured all come under engineering. We cover biomedical engineering. We've got systems engineering and management, clean energy, marine engineering, robotics and intelligent system, aerospace. Now behind it, you just have a look at just how many different areas that mechanical engineering is involved in. Just give you a few seconds just to absorb just how wide mechanical engineering is, that our faculty are involved in. It is so many areas. It's not about just repairing a car engine or working in a power plant. Okay, so it's very, very broad. So this is something that we are very confident of, that if you join our school, take our degree course, it will set you up for a very, very secure future, because there are so many engineering areas that you can be involved in. So what our nation will be in the future. So I think this is something that is ongoing. Industry 4.0, robotics, smart nation, IoT, and so on and so forth. You find that engineering, a degree in engineering will set you up for this future. Many of the other disciplines may be in decline because you see that the computers and robotics are basically taking over almost every aspect of life today. And it's basically the engineers that will survive because they are the ones developing all the new systems that all the other disciplines are using. So having a core degree, one of the best first degrees you can do is always taking up a degree in engineering. Here are some of the slides on the innovation, the kind of work that our students, this is that our students get involved in. Remember, I was telling you about hands-on industry-based projects and all that, to make sure, because it's not about just learning the course, but it's about putting what you've learned in practice. And these are some of the examples of projects that our students have done. We are very proud of this Eco Venture series. In our innovation lab, our students built the 3D printed cars. There are so many different cars. Now we are in, I think, version 11 NTU Eco Venture. And students join the various research centers and numerous labs we have in our school to basically do projects of this nature. Okay, here's a also, we in our school, we are now focusing on more on hands-on engineering. Okay, so that our students are well-rounded and not just on the theoretical side. Because when you are building and developing, you need to be able to be familiar with the building processes and machining systems and how to solder your circuit boards and things like that. So this is something that we have now allocated 6 hours so that you are all trained in practical hands-on. Some people say in some universities, the engineer doesn't know how to change a plug, or rewire something. This is very bad. So this is something that we make sure that our students are well-rounded in the practical aspects of engineering. Okay. As I want to emphasize, joining our school is not about just learning and attending lectures. I know now most of the lectures are online, but it's about the experiential learning. This is where you really learn, when you put your hands on to build something. This is where the real lessons are. So the real lessons that you pick up as an engineer are gained in our research labs, our innovation labs, our studios, and many of our corporate research centers as well. So once you actually get hands-on into developing, hands-on in projects, developing and taking on actual challenges, solving real engineering challenges, that is where the real learning is. Okay. We also have this culture of creating many opportunities for our students to do hands-on projects. So that's why in NTU we have 5 maker labs, of which there's 1 maker lab in MAE, our school. Okay, and this is entirely exclusively for the use of NTU students. So any and everything that projects that you want to do, you want to try and build something, formulate something, go and visit our makers lab. Okay, the facilities are there for you to do 3D printing and create your circuit boards and so on, to basically be comfortable with creating. Suddenly you find that once you join our schools, so much resources are available to you that basically your eyes pop. And it's just to provide as much opportunities and for our students to be able to develop themselves as an engineer once they join our school. Also, when you join our school, we have very good industrial exposure. We have a Dyson studio. I'm the director of the Dyson studio in our MA school, okay, and it serves the entire university. You work with our Dyson engineers on different projects. They will coach you on this Dyson philosophy. Same with, we have our HP Corp lab as well. So again, you have the opportunity to mingle with HP engineers and develop and work on the projects, research projects that HP is working on. So these are things that when you select a university, you select a school, choose one that has a lot of very good industry links and collaboration with different companies. See how much corporate labs they have. These are just opportunities that are available that joining our school will give you. Okay. The other aspect of engineering is that for students who are inclined to do research, we have this research program called the Eureka program. Okay, and this gives you a lot of, again, different opportunities to cultivate and grow your research potential. Now, in our school, this is something important. You need to know the structure of our school education or degree system. Okay. So in our school, the mechanical and aerospace, and here in this talk, I'll just focus on the mechanical engineering degree program that we offer. So we offer, besides the core mechanical degree program, okay, we also offer these options: mechanical engineering with economics, mechanical engineering with minor in business, mechanical engineering with second major in business, mechanical engineering with second major in society and urban systems. So these are all add-on options you can do with a mechanical engineering program. Okay, now I'll move on to the other options that are available to you. Okay, so in our school, when students join us, we have these 3 core streams. Okay, so we have the regular mainstream core, where the bulk of the students will join, and they will continue this all the way to four years. Then we have the design stream. For those who want to join the design with inclination towards design, I'll talk more about this later, as well as mechatronics stream. These are when students join in our second year. They select these 2 streams, and they start from the second year. Okay. Now for the mainstream students, okay, these are the kind of modules that are core modules that we'll be studying. You can get more information from the website, as well as the prescribed electives that you do in the final year. Okay. Now, in the final year, we have what we call, for the mainstream, specializations that the students can do. Okay. And these are the specializations. You can always more than welcome to visit our website to see more details and the subjects under this specialization. So we have aeronautical engineering, system engineering, manufacturing engineering, naval architecture and marine engineering, and smart manufacturing and digital factory. So these are the streams. Now, specialization. The 2 streams, the design stream and the mechatronics stream, do not have this option to choose this specialization in the final year. It's only for the mainstream students. Now, for the design stream, there are students join in the second year. So the emphasis is obviously to develop our students for creativity, technology, and design methodology. And obviously, the stream cultivates students to have this thinking, this design thinking. They take on projects. This is a typical project breakdown that our students do. They identify the problem, they develop the concepts, and do the electronic programming. This is a Braille communicator for the visually handicapped. So this is just a very quick overview of how they develop the project of a Braille communicator for the blind. Okay, so this is just some slides, and of course they also have to develop the mechanisms, the electronics inside. So this is just a quick 3D graphic of it. Okay, so there's a lot of details. This is a very quick to show you that our design are not just draw the pretty pictures, but they have to understand the true design philosophy and develop what they're designing, build what they're designing as well. Okay, this comes to my stream. I'm the director of the robotics and mechatronics stream. It's very endearing to me. And obviously, this is something very prevalent in this current industry 4.0 and IoT. So obviously, robotics and mechatronics is very, very multidisciplinary. with the integration of mechanical engineering, electronics, computer, and intelligent control. Okay? This is an example of Edgar, a robot, which we're very proud is sitting in our robotics center, and he's been on show in the National Day. Okay, this is my 4012 mechatronic system design. This is something developing autonomous vehicles, able to compare, collect both. So there's a lot of learning when it comes to my class. I find that so many things that you can learn as a mechatronics. This is an example of a disinfecting robot built by one of our professors' company, Transformer Robotics. There's quite a number of our professors in our school have their own personal company. Even I might have my own company as well, developing on the research that we do. So these are all the opportunities that you have when you join our school. Okay, this is a photograph of me in my class. Okay, that's me sitting in the center there. Very proud to see all the happy faces and all the different robots that they developed. Okay, so very quickly, this is just a very broad view of the different companies. So many. One of the strong points that you join our school is that you get to know our career attachment office. I work closely in my position as the assistant chair for alumni development. I work closely with the industry, and it's about opportunities. I know if you join other universities, you study the courses, but we connect you with the employee. We've got work study programs and many opportunities, because these companies approach our career attachment office, and we have our career advisor as well, who look through and tell you what are the options available. You tell us also what you like to do. We will find the attachments for you and connect you with all the different companies. So if you join a school like us, because we are so big, we are connected, so well connected with the industry, this is where the opportunity comes in. You don't just join us because you want to study a course, but we will basically connect you with the industry and get you your job as well, so that the company knows our students and you know the company. So this is something that I'm very, very proud of when you join our school. Okay, now just in closing my talk here, this is something that's just fresh off the MOE and EU Graduate Employment Survey, just came out in 2021, a few days ago. So this is the rate, because now the COVID may be slightly affected. So yeah, some people say the numbers, despite the COVID thing, the numbers are still very respectable. This is in 2021. Many people say, oh, employment rate down, our companies closing, but hey, our MAE graduates still have a 94% employment rate. And the general mean gross salary is about 3,800. This is the mean. Remember, our school is very, very big. We've got 600 plus students intake, okay, plus the aerospace as well. So this is something that we're very proud of. Despite of the COVID 2021, COVID-19 pandemic, our students are still getting very good employment and very respectable salaries. Okay, so I'll close my talk here. If you have any questions, you can feel free to contact me, and the details you just ask the MAE faculty this email. And also, please stay on. We have our next talk, our student Basni, giving you a talk about his perspective. Okay, so I hope to see you around in the school, and I hope that we have helped you make a good decision to join our school. Thank you very much.
Vamsi, over to you.
Yes, I'm sharing my screen. Yes.
So Vamsi is actually the president from NTU Robotics Club. So if let's say you're interested in to know what the club is doing, what kind of opportunities they would have, feel free to ask Vamsi and Dr. Heng on his experience in terms of the curriculum during the Q&A session after Vamsi sharing.
Yeah. Can you all see my screen?
Yeah.
You can see your screen. Thank you.
Yeah. Okay. Thank you, Prof. Jonathan, for sharing us about the MA activities as well as robotics clubs, robotics stream. Before I get started, I'd like to thank you for taking time of a weekend to learn more about MA and what robotics stream is about. I'm a final year student in robotics and mechatronics stream, and I'm the president of the robotics club as well. So today we'll understand what this club under School of MAE is supporting all the students of MAE in developing their skill set to become great robots in future. I shall start off by telling you about our mission and then go through some of our events which we organize and how we participate in competitions, and to participate in those high level competitions, how we prepare our students and how the curriculum of is helping along with the robotics club to help the students to compete in competitions internationally. So our mission is to gather individuals from diverse backgrounds to grow and share one's passion for robots, and we are formed by students from computer science, electrical engineering, as well as mechanical engineering backgrounds, because robotics is an amalgam of all three backgrounds. So we need all three people, and we work as a group, and then we build cool and intelligent robots. So, but what are our objectives? Our objectives are to give a glimpse of how the real world experience of working on robots will be, and how to participate in world class competitions as a part of our Mechatron team, who are the students who are very curious in proceeding further with robotics, or who even not don't know whether the robotics is for them or not. This will act as a good the stepping ground to start and playing around with. So we'll be conducting a few talks with professors like John Eng, and some industries like other companies like Panasonic, Eureka Robotics, etc., like who are A-Star, who are performing world-class research in the field of robotics, and that will help students to get a more glimpse of how industries are looking at. And finally, we hope to build a robust network to help connect with different robotic enthusiasts in Singapore, all over the world, as well as within NTU, because we have one robotic research center where our club is in collaboration with. So these are for some of the few events which we have organized since past few years. So this is a Pi Bullet is just a physics simulator where you can try out different robotic stuff. Here you can see a robot arm drawing a hello as introduction, and we train people to get to know about Python, image processing, how a robot works, etc. And this coming to complete software, a bit introduction to microcontrollers. So this complements one of the course in year two. If you took robotics, then in year two you have mechatronics course where you will be playing around with Arduino. And in our case, we had to build arcade game as well, like arcade game, like which if you go to movie theater, you can find arcade games. So we built something similar to that with just Arduinos. And these are some of the workshops which we conduct to complement the course, which is a part of MA curriculum. And computer vision is basically a part and parcel of all the robotics applications. So we introduce machine learning and deep learning as well. So we have collaborations not just with industry partners, as well as with internationally clubs as well. From one of the top Indian universities, we have partnerships, and the Robotic Research Center in NTU, which is quite big. And as Prof. John mentioned, we have Edgar robots. So there are lots of other robots like dual arms, mobile-based robots, where people can some undergrad students, if they're interested, as a part of Eureka, they can participate in this project, as well as through club also, you guys can start working on that. And this is a Lunar Innovation Challenge, which we are conducting right now in partnership with industrial company Neo Aeronautics, Aspire Incubation Labs, etc. And we planned, this is almost like half a semester project, and the winners will actually get a chance to showcase their work to a US astronaut. And this US astronaut is a alumni of our MAE, and who will be visiting Singapore on a short visit. And during that time, we plan to showcase our the winners. And if the astronaut is interested in the project, he's actually considering to help the projects to become a real NASA project as well. So this serves as a very great opportunity for all the students to prove their skills. And this is a Megatron team which has been giving great results since past 5 6 years, like since the club has been started. So the left side RoboMasters team is basically a competition where a team of robots compete with another team to in a arena like RoboWatch. And this is our team who won a second prize internationally by competing with 7,000 students all over the world in China. So, and this is the right side, you can see another robot, which is what we are currently working on for participating in the Singapore. This is an autonomous robot which goes underwater, and there are few tasks which it has to do underwater to win the challenge. So last 2 years back, we won. We were placed in the top 30 teams all over the world, and this year we are participating again with the upgraded version of the robot, the second version, which you can see is a black one. So this is how technical it's going to look like. Like, I understand this looks quite overwhelming. That is the reason to get all the students to almost this level of expertise, we have up projects. So we start off with simple simulations where you can see the robot arm. This robot arm design was done completely by students from the core fundamentals which they will learn from the MAE curriculum. And there are a few design modes as well, like machine element design, engineering graphics, and there's a major PE in year 4, which is basically an elective where you can choose robotics as your elective, and there you will be learning how to design a robot arm, what is inverse kinematics, and how to control all these arms. So that's where using all those principles of the club, students have able to design these arm, and they were able to play chess, and some students even mounted that arm onto a moving platform so that it can move all over this virtual world and do some tasks. And this is just a simulation. So, and this year, like, we from simulations, we want to test it on real robots as well. This is a Turtlebot 3, which is an open source platform where you guys can test a lots of stuff. Like, for instance, it can go from point A to point B, deliver some stuff if you mount a robot arm. That's what we are currently working on. And it can say it can act as a greeting robot, which can go and introduce itself to everyone. So for that, we'll be conducting personalized workshops for depending upon the project. Like, if your project needs related to ROS is a open source framework which a lot of industries are using, and that's what we plan to introduce. And a lot of students are benefiting a lot and are able to get in the internships in a much easier fashion with experience with ROS. And to summarize, we have 3 main paradigms of our club. One is events, one is projects, one is competitions. Events serve as a platform for people who want to try out how robotics would be to come and join our workshops. And the ones who are a bit more serious can commit for almost 1 semester in our projects and to hone their skills. And once they're familiar with the projects and complementing the fundamentals of the MAE curriculum, they can participate in competitions. And all this is supported by a lots of MA prof. Prof Chai is one of our club mentor who is also teaching some modules in robotics curriculum. Thank you. I hope to looking forward to see you at MA. If you guys have any questions, please drop it in the chat.
Okay, so as we wait for the questions to flow in, maybe I'll ask Vamsi a question. So, Vamsi, can you just share with us, what made you choose robotics stream, and what kind of future do you see for yourself, when you're graduating? Because you mentioned you're in your 4th year, is that right?
Yes. So how I chose robotics stream is specifically, okay, I chose NTU because of robotics stream, because the Robotics Research Center at NTU is quite robust. And right now, for my final year project, I am working in Robotic Research Center too, working on research robots like Heavy, which actually is useful in doing assembly tasks like with Scaffler Lab NTU, which is used for industrial automation. And how I see myself after graduation is like there are really tons of opportunities in Singapore, especially for robotics, and Singapore government is pumping in a lot of money to automate stuff. So I'm specifically interested in autonomous driving, and so that's why there are lots of companies like DZ, SV, which I'm trying to get into, and Motional, and all these companies which are competing with the US giants like Tesla for autonomous driving as well. So all these have branches in USA as well as in Singapore. So, and they value NTU graduates a lot because they know that the fundamental background which the NTU students have is quite robust. So that's the main reason why all these giants like Motional, the DZ, and like there are lots of startups which are coming up as well, which are going to autonomous robots and industrial robotic. Like for instance, a startup from NTU itself, like Eureka Robotics, headed by Prof. Farm, is doing quite really well, expanding quite really well, and it's even a part of MIT Exchange incubator program as well. So the robotics stream is quite robust in NTU, and the future is quite bright.
Yeah, thank you, Vamsi. So just to carry on to your questions, because I think earlier you did do a little bit of sharing on the rover project, right? We have a question coming in from Slido. Does NTU have a team that participates in the University Rover Challenge?
Okay, that's something which is currently being formed this year. Like we have grouped in a pool of students who are quite interested in rovers. We have another club which is dedicated to space, like SCDS. But then this year we are planning to create the rover team. Like mostly by next year, you will see something going on with the rover.
So actually, from my experience with the robotics club, actually, I think over the years they've undertaken many interesting projects. So I remember maybe about 2 years back, they had this idea for an underwater submarine robot, which was pretty cool because how else do you make a robot, function underwater? And it's a student-made project, so it has to be like water resistant. So that was really amazing for me. And I do know that before COVID set in, we actually have a lot of students that actually took part in a lot of overseas competition. They went to China, they went to a couple of countries, with their robots, and they took part. So in a physical open house, you would be able to actually see some of these projects. But now that we are virtual, fret not, because next week, in one of our tours, we have 2 tour dates on the 23rd and 26th. One of these trips will be made to the Robotics Research Center. So Vamsi did share, we have Prof. Farm project there, even our current dean from the College of Engineering, he has created a medical robot that helps with surgery. I think you may be able to see it there. So sometimes these projects, they go out because they are there for real life application. So they're out, in the hospitals on site to do the testing. So it's a surprise every time you visit. Different projects will be there. Maybe Dr. Heng, you want to share a bit more about, how you ended up in robotics and what kind of exposure you can possibly provide to the students as they undertake this, an undergrad degree with us. And Dr. Heng.
Okay, thank you, Eileen. This is a question that I get asked by many students. I think it's self-explanatory, simply by virtue of the economy and where we are going, industry 4.0, IoT, and so on and so forth. So many processes in the industry are being automated and more jobs are being done by robots. I think it's a very good indicator of how this economy is growing by the number of robotic companies being created in Singapore. Last time, if you look at 10 years ago, you ask how many robotic companies, probably count less than number on one hand, the kind of thing. But now you look at our faculty, as Eileen mentioned, our Dean of COE, Prof. Fee, he has got 2 companies. One is EndoMaster that does surgical robotics, and the other one is EndoPill, the one that this pill that you swallow that solves your weight problem. Okay, so that's one. We've got Prof. Chen Yiming in our school. Yes, he's got his transformer robotics. And then we've got Prof. Pham, who's got his Eureka robotics. Okay, and then for my company, I've got Symphony Private Limited. We've got the director of the Robotics Research Center, Prof. Domenico. He's got his Articares company. So this is an indication that a lot of the robotics faculty are starting companies. So we won't be starting companies if there wasn't a need in the industry. And obviously all these companies require jobs. So if you find that there is your inclination to solve things with automation, intelligence, using a robot to solve many problems, because this is something that we engineers like to explore, just how many things robots can do in our daily lives. It's a very fantastic opportunity. So when you join our school, you get to meet faculty like us, okay? And we get to share with you our stories of our adventures in creating companies, in solving problems in industry, and many of the challenges that we see have a robotic solution might just be the ideal situation. Say robotic surgery, the robots can do the surgery even with more precision and accuracy than the surgeon himself. And then with EndoMaster, okay, the company that the Prof. Fee has developed, that one is endoscopic surgery. So you have a very little minimal scar when the surgery is being done. Okay, so you find that when you join our school, okay, I know you have to make a decision of many university choices, but many of our students tell us after they've done all the extensive research, they find that the NTU and the school MAE presents the best option for them to join, to give them many exposure in this field. So I hope that you join us if this is something in your inclination to develop and study in the world of robotics, automation, mechatronics. Then please consider us. Look us up. Speak to us during our open house. We will share with you the projects that we've done, the opportunities that lie with you. When you connect with our career attachment we'll connect you with our career attachment office. They will connect with you, tell us what you like. We will connect you with the companies. We introduce to the companies that are interested. I did a visit to a company out in Changi, Lions Board. They do the cleaning robot, extensive, the vacuum mopping and all that. And they are also looking out for engineers to develop their project. So this is something that you just need to speak to us to know where the opportunities are, and we'll connect you with the industry. Yeah, thank you so much.
Yeah, thank you, Dr. Hing. Just to echo on to Dr. Hing's sharing, I really feel that, in terms of robotics, rather on top of it, as the society, we move into industry 4.0, as we move towards automation, actually robotics, they actually do help to make an impact in our everyday lives. So in Dr. Hing's slide earlier, you can see that one of our professors, he created this disinfectant robot to address COVID situation. The EndoMaster robot that Dr. Hing also shared with you, created by our Dean, Louis Fee, is also to actually improve the surgical accuracy, and also to reduce the scarring on individuals. And we also have our professor that created a 3D robot to help with 3D printing toilet to actually address some of the sanitary issues in less developed countries. So a lot of these are actually meant to also help and impact, to make a positive impact in our today's society. I've seen one more question coming in from Slido. At the same time, for our Zoom audience, if you have any questions, just feel free to drop them in our comment box and we'll get back to them. We have time for about one more question before we wrap up. So the question from our Slido, it's, after year one, based on what criteria or score students are granted with robotics stream? How many % of students get into robotics stream after year one? Dr. Hing, are you able to address that?
Okay, yes. The intake for the robotics stream is very competitive. We currently, this year's intake, we have 107 students coming in from the second year. We are looking to increase our space and resources in our school, because training the robotics students joining our robotics and mechatronics stream is not something easy to manage. It's not something that we just open up the lecture, they all attend lectures. In fact, the robotics and mechatronics stream students play with the most equipment, so they require the most lab space and the most amount of resources available. And this is something that we have to only gradually create. We are expanding, we are renovating our labs to improve the intake size. So every year, when the students have finished their first year, obviously they will select the choice for the robotics and mechatronics stream. And depending on the applications that we see, we will have to make a decision, because we don't have space for all the applicants. As I said, the last year's intake was 107 students. So we have to assess and our students, and you'll also be joining with students, the first year students, as well as those that are coming in directly as a second year student. So there is assessment. We do check that you do take the relevant subjects to offer, and the cutoff that we have to decide from year to year. So I mean, I can tell you the cutoff, but it makes no basis for next year's intake. But I think this will not apply to you just yet, because for those who are coming in the first year, you do the examination, you do well, then you select either design stream or mechatronics stream. But for those of you joining us and a direct entry, especially for the Polytechnic, then when we see your application, we will make the decision and award you the place. That's all. I hope, Eileen, I hope I've told you the information needed to answer the question.
Yes, thank you, Dr. Hing. We have a question from one of our Zoom audience.
Please.
He would like to know, in terms of content, what is the difference between NTU and NUS engineering?
Oh, okay. I've not recently gone into NUS site to have a look at the curriculum. Certainly, you can visit our website to see all the curriculum available. Okay, so these are two world-class universities, NTU and NUS, and we go to our strengths. So the strength of joining NTU, obviously, if you go to our NTU MAE website, click on the research areas, and then slowly you can drill down all the different research areas. That's our core strength. But in terms of size-wise, I think we are easily quite a number of times bigger than NTU. In terms of faculty count, we are double the size of NUS, and also the number of students we take in. So obviously, with more faculty come more research areas and more opportunities. So when I know I get asked these questions many times, and it's natural, and I totally welcome it, to compare ourselves, NTU versus NUS, which is the better or which is more suitable. Make your informed choice. Speak to faculty from NUS as well as speak to faculty from NTU, and see the key word is to see which area you are interested in doing. The area interested, and then we will link you up with the faculty and see whether you find that there's linkage in this, there's correlation in this, and then you find that then that will help make the decision. Basically, it's the opportunities that are given, they are open to you once you join the university. And obviously, if you join us in NTU, MAE, I'm very proud to say that the opportunities we have in our school is very, very extensive. And as I say, we work closely with our career attachment office, because it's something that is very important to our students. You come to university, what's the point? To train yourself to be a professional engineer, as well as to give your gifts, your value to society by doing a job. And this is something where we'll close the link up with industry to get you the job that you want. Okay, so this is something that I'm very proud of when you join our school.
Thank you, Dr. Heng. Maybe Vamsi, would you like to add on a little bit to share with the students how did you actually chose between the different universities, the different courses?
Yes, certainly. So I was quite interested in robotics. So when I was applying in my batch of 2018, NUS actually didn't have a specialization of robotics, and NTU had already been using the specialization since past many years, and that is probably the reason why NTU has so many research areas and so many robotic startups coming up, and so many faculty who are quite experienced in the field of robotics. So that's one major difference which triggered me in choosing NTU and specifically robotics. And another reason was the atmosphere, club atmosphere, especially like when I was joining, like NTU Robotics Club, literally one went to China and won in Robot Masters and internationally second level, participating, like competing with around 300 teams and over 7,000 participants. So that was a really big achievement. And since after COVID, like we weren't able, the competitions were put on hold, so we weren't able to proceed further. And this year we are going again. So those were the main reasons why I chose NTU Robotics.
Fantastic. Thank you, Vansi. Well spoken, huh? Don't hear from me, hear from our student.
Yeah. So, okay, guys, this is all the time we have for today. So feel free to keep the questions coming in on Slido. We have our staff, our faculties, and our students online to respond to them. So if any of you are considering a career in education in aerospace engineering, the next talk is starting at 12 p.m. So if you're interested, I'll see you there. So thank you everyone for staying tuned to today's robotic sharing. See you again in NTU soon. Bye.
Okay, thank you. Bye. Make the right decision to NTU and AE.
All the best, guys.
All the best.